Welcome to SIMAC. SIMAC is a linear accelerator simulation program that allows users to understand the effect of accelerator beam adjustments on the physical properties of the clinical beam. It's kind of like a flight simulator, but for medical Linacs. Once SIMAC is started, you get a screen that looks like this. At the top are the physical parameters that describe how the Linac beam is set up. This includes things like RF driver power, Klystron pulse voltage, gun voltage, and bending magnet current. Also at the top are other beam parameters that depend on how these more basic parameters are set. These are things like target current and dose rate. At the bottom left are sliders that allow the user to adjust the electrical inputs to SIMAC. Not only does this include modulator parameters, but it also includes beam steering parameters, jaw size, and pulse width. To start the program, first turn on the beam. With the beam on, choose an energy and a pulse repetition frequency, or PRF. Once they are chosen, the program displays the Linac's operating state, including a dose rate, which is calibrated in real physical units. Adjusting any of these four parameters on the left here will change the physical characteristics of the accelerator's beam. For instance, increasing the Klystron pulse voltage will decrease the dose rate of the unit. This is because the Linac beam energy increases when the Klystron pulse voltage increases and causes a mismatch with the pass through the energy of the bending magnet. To better understand the physics of the accelerator beam, SIMAC includes three other screens which show the operating mode of the Klystron, the accelerator itself, and the treatment head. Clicking on Klystron brings up the Klystron window. This shows a summary of the Klystron's operating point, including the saturation curve. The user can also view some important pulse waveform on a simulated oscilloscope. Also shown are some educational values that are not obvious, even when servicing an actual unit. These are the Klystron's gain and efficiency. The accelerator window shows the behavior of the accelerator depending on how it is set up. The measurable parameters are the RF input power, the gun current, and the target current. Also shown in the accelerator window is the accelerator's operating point on its load line. A readout of the accelerator beam energy is also included. In this instance, the accelerator beam energy is 15.33, which is higher than the nominal 15 that we set when we turn the beam on. This is because when we increase the Klystron pulse voltage, we increase the electron beam energy. The last window in SIMAC is the treatment head window. This shows the effect of the beam position on the target on photon beam symmetry. Changing the steering coils of the Linac changes the beam's position on the target, shown on the bottom left of the treatment head window. It also changes the dose profile in water, which SIMAC also shows. SIMAC includes a 3D dose profile in water to simulate the type of observation a clinical physicist would observe when the service engineer adjusts the accelerator settings, either at regular QA or when repairing a Linac that isn't functioning. We hope you enjoyed this short demonstration of SIMAC. If you would like to use it, please consider taking the Accelerator Technology course offered at the Princess Margaret Cancer Centre through our Accelerated Education program.